Good morning, everyone. Let us start with day 2 of operating system subject. So in the last class, we have seen basics of OS. What do you mean by kernel? What do you mean by user mode? What do you mean by, you can say kernel mode? What is user space? What is kernel space? Then we have seen the concept of mode bit. There is something called as system call. If I am executing any program, then we are in user space. And if there is a call which is done by your operating system, and when the operating system performs some operations, in that case, background may there are certain system calls that gets executed to perform certain specific tasks. Also, we have seen in case of operating system, we have, you can say, different categories of system calls, and that was the last topic in the last lecture. In today's lecture, we will specifically focus on process topic, which is called as process management. Now, when you talk about process management, today we will see what is process, what do you mean by process descriptor table, or you can say process descriptor or process control block, and we will see the concept of different scheduling criteria when you talk about processes. So let us start with the difference between what is process and the program. For example, you all have written a number of C programs. So assuming I have written something called as program.c, and assume it is available in my F drive, let us say C folder, C programs folder, right? Now, when you create this program, then this program is basically written in C, having the extension .c. This program is having some specific task that is to be performed. So anything where we write some set of instruction to execute or to perform some task is called as program. Now, F drive is available in my hard disk drive, which is called as HDD. Now, when you talk about program.c, at this stage, this program is basically not in the execution phase. When you try to compile this program, obviously you get from program.c, you get one output file, which is nothing but a.exe. So from this, I'm going to get a.exe file. Still, this a.exe file is available in my hard disk. It is not in the execution mode. Now, when you give the command for the execution ./a.exe, there comes the you can say picture of loader. So what does the loader will do? Loader will take your program from your hard disk to RAM, which is called as main memory, right? This is the job done by the loader. So this is my hard disk, and now in my main memory, that is in, let us say this is my RAM, which is allocated it is having some specific size based on your machine requirement. And now what will happen? This a.exe will get loaded into some memory area, maybe let us say over here, and here mera a.exe program load kiya jayega. When I say the program is available in the main memory, then at this stage, I will give this program a name called as process. Because it is in execution mode, so any program which is in execution mode is called as process. So when we talk about when the program becomes a process, it is basically when the loader loads your program from disk to the main memory, it becomes the process. Any program which is in execution mode is a process. Any program which is available in the RAM for its execution is a process. So जब तक मेरा program main memory में नहीं आता है, तब तक मेरा program ही रहता है, process नहीं रहता. Have you understood the difference between what is program and the process? So a process is an instance of program in the execution mode. So the MCQ can be in the form of any program in its execution mode is called as what? Answer is process. When you talk about in another language, running program is also called as a process. When the program gets loaded into the memory, it is also called as a process. So these are some of the definitions of process. A program is set of instruction given to the machine to do some specific task. There are 3 types of programs. One is user programs. I've given you the explanation about this in the last class. Any C file, any Java file, any Word document, any PDF file, anything, any file that you create, that is nothing but user programs. When you use different applications, then those are called as application programs. So you have applications so that you can write your programs and perform the operations. Then you have system programs. Maybe you have device drivers, interrupt handlers, etc. So that is nothing but system programs. You have compilers, interpreters, drivers, and so on. All these are called as system programs. There are basically 3 types of programs that we have seen in the last class. Now, we are going to the topic which is called as process management. That means, for example, I'm saying I'm switching from Paint, I'm switching to this PDF file. Maybe I am going to some folder. Maybe I'm going to Zoom. Maybe I'm going to this Chrome browser. This is basically called as number of processes are available in my system on which currently I'm working. But when I say all these processes are currently on which I'm working, then in that scenario, जब मैं इसको minimize करती हूँ या जब मैं फिर से उसको maximize करती हूँ, then that exactly is called as management of processes. What is management? Maybe I'm creating a process, maybe I'm closing that application, maybe I'm suspending it for some time period, maybe I'm resuming it back, maybe I'm minimizing and back I'm maximizing it, it is resuming. Maybe I'm saying now I want to go for this process to execute first, so I'm changing the priority of that process. Maybe I wish to stop some process execution, that is blocking the process. Maybe I wish to dispatch the process from main memory to disk and disk to main memory. And then there is something called as inter-process communication, where I need to communicate, one or two processes can communicate with each other, that is inter-process communication. So जब मैं बोलती हूँ मेरा process is moving from F drive to this, or my process is when I'm closing this application, in that case, this can be brought back to your hard disk, right? This is called as dispatching. So there can be multiple number of tasks or the services that the process includes. Maybe creating, destroying, suspending, resuming, changing the priority, blocking, dispatching, and maybe some process wish to communicate with each other, that is through inter-process communication. So when I say these all are the different tasks that are performed by my operating system specifically on the processes, then that is called as process management. So there are different categories, how your memory is managed, how your files are managed, how your disk is managed, how your processes are managed. That completes is the basic functionalities of operating system that I have mentioned in the last class. So today we will focus specifically on how your operating system manages different processes together. Right now, for example, when you talk about memory layout of a program and the process, for example, in this example, we have created a program.c. जैसे ही मैं program.c बनाती हूँ, my operating system gives me some block, which is kind of information, where I will have exe header or primary header. What exactly it is? It is basically consists of basic information about your file. When it is created, how it is created, what is the extension, what is the size, what is the start date, what is the date of creation, time of creation, start of the file, end of the file. Pura information is kept into this header, which is called as primary header. Next, I hope you remember I've given you just introduction about this in the last class too. When I say static variables, global variables, when we declare them, they are basically uninitialized. All the uninitialized static and global variables receive the memory from the block start by symbol called as BSS section. When you initialize those static variables, when you assign some value to those global variables, they are moved from BSS to the data section. If you declare some constants, some specific literals, some specific enum constant जैसे हमने declare किए थे C में, they receive the data into the RO data section. RO stands for read only data section, the section in which I will not be able to do any modification on my data, that is RO data section. The code, the text section, they contain the executable instructions. Means your remaining line of code will belong to this section. Symbol table consists of all the variables that you have declared and defined inside your program. तो जब तक आपका program hard disk में है, the program consists of these many things as a memory layout. But when you say, I wish to now execute this program, then program becomes the process. When the process gets started, your operating system first checks the header. It checks which is the starting memory location of the file. What is the basic information about the file? It fetches that information from this primary header. That's the reason when the program becomes the process, this section is skipped, because यहाँ से ही वो information fetch करता है operating system और आपके program को process बनाता है. While execution of my program, obviously it has to maintain what are the static, what are the constant variable, what do you mean by code, what do you mean by text, and so on. So these states it will keep as it is. Along with that, symbol table में पहले वेरिएबल कौन से डिक्लेयर है, अगर अनडिफाइंड रहते हैं तो वो आपको एरर देता है कि कंपाइल टाइम पे ही एरर देता है, वेरिएबल इज अनडिक्लेयर्ड. So symbol table maintains the table. It is kind of a table which will maintain list of variables or the literals that you have used in your program. So that means जब मेरा program process बन जाता है, that section is also skipped because you have because you have already defined that variables, declared those variables. Along with that, when you talk about process, when the process program becomes the process, at that moment, this is stack section and the heap section, they get added into your memory area. These are the temporary memory allocation given to each and every memory area. When you talk about stack, आपका local variables, your intermediate operations, the array declarations or any variable declarations जिनको memory चाहिए, or for example, in your function activation records, all they gets the memory into the stack section. Similarly, when you talk about heap section, if you talk about static memory allocation, जैसे आज हमने array topic देखा, तो in case of array, we were defining its size. That means I need 5 elements, I need 10 elements. In that case, I will go for stack section, right? But if I do not know that how much array elements I require at runtime, in that case, I will go for dynamic memory allocation. So what is dynamic memory allocation? Whenever I receive the memory in the heap section, I will talk about that memory area is called as heap section, right? Now, when you talk, Saurabh is asking, एक वेरिएबल डिक्लेयर किया बट उसे यूज नहीं किया तो वो सिंबल टेबल में होगा क्या? यस होगा. यूसेज के लिए आई हैव अ स्टैक सेक्शन. Symbol table will only maintain, for example, you are saying I have declared integer a, integer b, and maybe you are writing integer a comma b. So these are the two literals that you have used in your program. So it will maintain a table. Maybe it will assign, okay, a variable, I'm giving some memory area, let us say 4000. B variable, I'm giving some memory area 4004. Now it will check, is this variable is assigned some value? Yes, तो यहाँ पे suppose 10 value दिया, यहाँ पे 20 दिया. अगर नहीं भी दिया, तभी भी ये तो मेरे symbol table में रहेगा ही, because this is called as a literal table. So whatever number of variables you are declaring in your program, those can be used in the literal table, or those can be defined inside the symbol table. अगर suppose मैंने यहाँ पे लिखा in my program, suppose I'm saying printf and I'm saying %d and I want to print a variable var, but var का मैंने declaration नहीं किया है. In that case, this will give you the error. Var is undeclared. Why? Because its entry is not available in the literal table. I hope, Saurabh, you have got your answer. Okay, so are you there, Saurabh? You can post yes if you have got your answer.
मतलब अनइनिशियलाइज वेरिएबल हमारे प्रोसेस में भी रहेगा.
बोथ
प्रोसेस में भी रहेगा,
सिंबल टेबल में रहेगा. वो
प्रोसेस में रहेगा क्योंकि लिटरल्स आपके आरओ डेटा सेक्शन में है ना. आरओ
डेटा सेक्शन में सिर्फ लिटरल कौन से रहते हैं? कांस्टेंट्स. कांस्टेंट which RO stands for read only. Okay, read only means you will not able to identify, or you will not be able to perform any modification into it. Constants. Okay.
Yes ma'am, thank you.
So this is basically called as a process, right? So when you talk about process, these all are the sections which remains as it is, and stack and heap, these two sections are added in every process for your intermediate operations. Next, now when you talk about any program, when you create any program, in that case one structure gets created for that program. In that case, that structure is called as process control block, which is also called as process descriptor. So when an execution of any program is started, one structure gets created for that program and process to store information about it. Maybe for controlling its execution, such a structure is known as PCB. PCB is process control block. Okay, now, so in short, if I'm saying I have created program.c, is it that program? Yes. Whenever I create a program, backend mein your operating system creates a block, creates a box, creates a structure to maintain the complete information about your process. PCB is process control block. What does it have? It will have a process ID, right? Every process, when it becomes every program, when it becomes a process, it receives a unique ID that is called as process ID. Process state, there can be multiple number of states. I will talk about state afterwards, maybe after 10 to 15 minutes. The memory management information, This process is taking how much memory, this process is located at which memory area, that information. CPU scheduling information, we will see different CPU algorithms, CPU scheduling algorithms, कौन सा process कौन सा algorithm use कर रहा है. The program counter, it means it will basically track, or it will keep a track of which instruction is to be executed next. That is called as program counter. Exit status means whether my process have been exited successfully or not. Whether मैंने उसको end task कर दिया, whether उसने मुझे error दिया, whether मैंने उसको directly close किया या फिर मैंने save करके close किया, power cut हुआ तो मेरा process चला गया. So exit status was normal or abnormal based on the situation. It maintains the status of that process. Execution context means how your program is getting executed, whether it is basically executed, is it using stack allocation, is it using heap allocation, तो उसका context क्या है program execution का. Next, which kind of IO devices it is using, is it using keyboard, is it using monitor, is it using printer, scanner. Complete A to Z information about your process is maintained into process control block. So this is also called as process descriptor. Without process control block, your compiler or your operating system will never understand what exactly your process is doing. Suppose yesterday I have given you example. I have a Word document which on which I am working on it. So that is one process which is in execution mode. From that Word document, I'm giving a print command. That means I am generating one more process that is also called as child process. So I can say Word is my parent process, which is generating another process, maybe a print command that becomes a child process. So in this process control block, process ID, parent process ID, child process ID, everything is maintained. That is called as process control block. Have you understood the meaning of what is PCB? Make sure you remember the full form of PCB and what PCB is called as. It is also called as process descriptor. Saurabh, pointer कहाँ पे जाएगा? Pointer local variable है. All the local variables receives the memory in the stack memory allocation. Okay, Saurabh. Ashwin is asking PCB will get handled by operating system. Yes, Ashwin, it is because आपका पूरा memory management, आपका process का पूरा execution, all these services, the one which we have seen, can be done by your operating system only. As a user, I cannot say I need this kind of memory, I need that kind of memory, I have this kind of algorithm to be used. It is a job of OS to maintain this complete information. Is it okay? So that is basically called as process control block and process descriptor. हीप में क्या जाएगा सौरभ? जब हम सी प्रोग्रामिंग में मेलॉक फंक्शन देखेंगे, मेलॉक इज बेसिकली जब मुझे रन टाइम पे कुछ मेमोरी चाहिए, डायनामिक मेमोरी एलोकेशन चाहिए, इन दैट केस आई विल गो फॉर हीप सेक्शन. ओके, राइट. So this is called as process control block or process descriptor. Now I was talking about something called as state. Whenever I'm talking about process, it has different states. For example, suppose I am starting a, let us say, new paint. Okay, this is called as creation of process. It means first time when I create a process, मैंने नोटपैड स्टार्ट किया, जैसे ही मेरा नोटपैड पे मैं वर्क कर रही हूं, it means it is the current process which is getting executed. This is nothing but which is being created. Whenever I create a process, it is basically in the state called as a new state. तो जब मैंने new paint start किया, at that moment, first thing that have generated by my operating system is a process control block for that paint. In that case, initial state which was set at as a new state. Now, जैसे ही I have clicked over here and I've said paint, means I have just initialized or I have just started the application. Sometimes it takes little time to start the application, but once the application have been started, when I'm seeing my paint in front of me, that means the process have been admitted into the state called as ready state. Have you understood? So the process, when it is being created, it is in the new state. These are the predefined states कि ये PCB maintain करता है, OS maintains inside the PCB. Process is waiting to be assigned to the processor, means background में कभी-कभी क्या होता है, paint open हो जाता है, but आपने उसको work करना start नहीं किया. That means right now also I have started my paint application. It was in the new and now it is ready for me to draw something or to do some task over there. That means paint application is ready for me. Its state is a ready state. Okay. Now, suppose I am maximizing now my paint application and maybe I'm drawing some diagram. Can I say I am working on paint application now? Is it my currently running process? Yes. It was ready at the previous stage. Now I'm in using that application. Whenever I'm using that application, it means that process state is running state. Means that instructions, means the task is getting executed by your process. Next, suppose I am working on this, I am in running state. But in between, I have minimized this, means it will go into the waiting state. It will go into the waiting state. So, waiting state के बाद background में मेरा paint ready है क्या मेरे लिए? Yes, again it will go into the ready state. So, have you understood up to this point, everyone? Right. So running is the instruction are being executed. Waiting, the process is waiting for some event to occur. That means when I say I have, let us say, performed, again alt tab, I'm coming to this paint. Again alt tab, I'm coming to the ready state. Right now, I'm in running state. Right now, I'm in ready state. So can you see, even though I am pressing alt tab, I'm switching from one application to another application. That is called as dispatching. When the process is getting ready or when the process is also in the ready state, then when I try to execute that process, it is moved from your ready state to the running state. And who takes it? Your processor takes it. And from ready to running state, this is called as dispatching. This is also called as scheduler dispatch. Right? Dispatching means when I try to process, when the process is moving from ready to running state, it is called as dispatching. Now, suppose I have written this, I have created a paint. Now I wish to go for print command. Okay. Now I wish to go for print command. In that case, if my process is basically in the running state and I've given a print command, my printer is busy, then it goes into the waiting state. Assume I have, let us say, just a second. Okay, suppose I have a state which is ready state. I have a state which is running state. I have a waiting state, right? So I have ready state, maybe running state, and maybe a waiting state, right? ऐसे भी हो सकता है कि मेरे मल्टीपल नंबर ऑफ प्रोसेसर्स यहाँ पे क्यू में हो सकते हैं. Can I say like this? Obviously, it is a possible chance, right? So if I say here, this can be a P1 process, maybe a P2 process, maybe a P3 process. In this case, I'll say, let us say P1 is my paint application, P2 is my PPT, P3 is my Chrome. I can switch from ready to the running stage. This will be taken by whom? By the dispatcher. Dispatcher will take your process from ready to running. Now, in the running state, at a time, only one process can get executed. Suppose running में अब P1 process execution में है. Now P1 have given, suppose, a print command, right? But printer is busy. That's why this print command will take my process P1 into waiting state. अब क्या होगा? Now this process P1 will come into the waiting state. So now what the dispatcher will do? Dispatcher will take next process, dispatch it from ready to running state, maybe process P2. Suppose this process P2 is also giving a print command. Means can I say यहाँ पे भी एक queue maintain हो सकती है which are in waiting queue, maybe process P1, maybe process P2. Can I say like this? Again, process P2 is also in the waiting state. Again, the dispatcher will try to dispatch next process, maybe the process P3. So P3 is moved into the running state. Suppose now I have closed P3. I have closed it. When I say I have closed P3, process is being terminated. So this will go in which state? Called as terminated state. I hope you have understood up to this point. Now, at the initial stage, I was in new state. Can it be a possibility that at a time मैंने क्रोम फिर पीपीटी वर्ड डॉक्यूमेंट पावर पॉइंट ये 4-5 एप्लीकेशंस मैंने एक साथ डबल क्लिक कर दिया तो कैन आई से यहाँ पे भी मेरे पास न्यू में बहुत सारे प्रोसेसेस क्यू में वेटिंग में हो सकते हैं P1 maybe P2 maybe P3 and so on. So can I say at these locations I may have different number of queues which can be available here also and here also. Are you agreeing everyone? क्या मैं टर्मिनेटेड स्टेट में क्यू मेंटेन करूंगी क्या? ऑब्वियसली नो, एक बार क्लोज हो गया. क्या मैं रनिंग स्टेटमेंट में क्यू करूंगी क्या? नो, आई कैन नॉट, बिकॉज योर प्रोसेसर इज एबल टू एग्जीक्यूट वन प्रोसेस एट अ टाइम. इवन दो आपका प्रोसेसर का स्पीड इतना ज्यादा है, आपको समझता नहीं है कि मैंने ऑल्ट टैप किया तो एक ही एट अ टाइम ओनली वन प्रोसेस कैन बी एग्जीक्यूटेड बाय योर सीपीयू. So these are the steps for it. Now suppose from the new I have ready state. Now suppose my process is being running, right? And in between my application got hanged, right? My application got hanged. In that case, can I say hang हुआ तो मैं उसको बोलती हूँ now please wait और let us say close. Close किया तो वो terminate में जाएगा. अगर उसको कोई भी इंटरप्ट आया या फिर उसने सिस्टम कॉल किया तो अगेन इट विल गो बैक टू द रेडी क्यू until and unless your processor, your operating system will perform that job. Right? Now, listen carefully. If you are saying I'm playing a music in the background, in that case, which state it is? It is in the running state. But the thing is, जब आपका processor है, it uses different combinations of algorithms that we will see today. उसमें से it contains which is the foreground process, which is the background process. So it can run two windows simultaneously. That is called as a processor is executing the processes simultaneously. It cannot be executed in the same span of time at whatever processor you have. One process at a time, only one process gets executed. Why do we say it is multitasking? Multitasking का मतलब क्या है कि मेरे प्रोसेसर की कैपेबिलिटी है मल्टीपल टास्क परफॉर्म करने की. It is multitasking. But when I say at a time only one, the speed of the processor is so high that your processor will basically try to execute in a so fast manner. तो आपको क्या लगेगा कि ये fast process हो रहा है, right? And all the tasks are. I'll mute all. Saurabh, I have muted. So that is called as all the processes are running continuously, right? So when you say minimizing, it may go from ready to running to ready state, because that is also one kind of interrupt, Haniraj. Okay, so if you minimize it, running से ready में जाएगा, maximize ready से running में जाएगा. Is it okay? Have you understood? If you want to install apps more than one in Play Store, then that's what Pawan I'm saying. At a time एक ही application execute होती है, but the situation is आपका जो सिस्टम है वो उसका प्रोसेसर इतना हाई स्पीड है कि उसकी स्पीड से आपको क्या लगता है कि ये सारे प्रोसेसिंग फास्ट हो रहे हैं. Now I will give you a easiest example. Suppose you are learning, let us say, car driving, right? And it's your first day of driving the car. Now first day रहेगा, so obviously what you will do, you will basically start the car, right? You will, let us say you are very slow, that means it's your first day, so obviously it will take time for you to learn the car. So you will first start the car, maybe you will change some gear, then maybe you will give some race, maybe you will give some brake and so on. Can I say I am performing multiple tasks while driving? Everyone? Can I say? Everyone? Yes. Suppose it's my day one, I'm learning from someone. So the person who is sitting next to me, that person will absolutely 100% realize that she is new in driving and she is performing the task one after the another. Is it what is the realization? Is it what I'm doing at the initial day one? Obviously, yes. But suppose maybe after 2 months, after 3 months, I may have a good confidence in driving. Then suppose the person who is sitting next to me, that person is not aware about the car driving. That person only is basically looking at me. At this point, now I have got a good confidence. Now my speed of handling all the operations, like giving a brake, giving a clutch, or whatever, increasing the speed, decreasing the speed, changing the gear, and maybe and so on and so forth. In that case, कैन आई से जो मेरे बाजू में जो पर्सन बैठेगा उसको समझ में ये आएगा कि ये सारे टास्क ये एक साथ कर रही है. Are you understanding the scenario? It is because now my speed have been increased, though I am not performing all the tasks together, but it seems I'm performing my tasks all together. Have you understood the scenario? Similarly, when you are talking about multiple processors, multiple, you can say, operations, in that case, your CPU speed is so fast that your CPU is performing multiple tasks simultaneously. Okay. Have you understood up to this point, everyone? Right. Now, suppose, I'll repeat, I'll explain once in short. Suppose मैंने नया application बनाया. Initially, I was in new state. I have said I have started 3 applications, so that is in the new state. I have said I have gone into the ready queue. Now this ready queue means all the 3 applications are ready for me. Suppose my P1 is the first application, which is paint, and I want to work on it. तो रेडी स्टेट से रनिंग स्टेट में लेके जाने का काम कौन करेगा? डिस्पैचर करेगा. So what is dispatcher? It's one utility which takes your application from ready to running state. But suppose now I'm minimizing this application, so running से फिर से वो ready state में जाएगा. Can I say it is nothing but one kind of interrupt or the system call where I'm performing a minimize operation? So it will take from running to ready. In the background, my application is ready for use. Again, when I press a maximize, it will go from this state to this state. अब समझ में आया? Ready से running and running से ready. But suppose I'm using any IO devices and my IO device is busy. In that case, those processes are put into the waiting state. Once the job is over, वो waiting से directly running में नहीं जाएगा, वो waiting से फिर से मेरे ready queue में जाएगा. Again, if I perform maximize, then only it will go into the running state. So can I say when I am in ready queue, when I'm in new state, it maintains certain queue of processes. When I'm in ready state, it also maintains some queue. Hey, when I'm in waiting state, then I have to maintain some queue, right? Ready to running process one by one जाएगा? Yes. The reason is running state में एक ही process at a time execute हो सकता है. Is it okay? So when you close that, app process has finished execution, then it is terminated. Have you understood 5-state process diagram? All right. Now, as I said, the state, when I'm in the new state, it maintains the queue. इस queue को मैं बोलती हूँ job queue. When I say my operating system maintains a queue, what all processes are ready, then this queue is named as ready queue. And when I say my processor also maintain the state who are in the waiting state, so that it maintains one data structure which is called as waiting queue. This is called as process diagram or process state diagram. So while creating a process or while execution of any process, ये सारा जो state का information है, ये कहाँ पे store होना चाहिए? Everyone? Where it will get stored. If I'm saying now P1 is running mode, running का state कहाँ पे store होना चाहिए? PCB. Very good, Ashwin. So PCB stands for process control block. So can you imagine कि हर एक process के लिए एक एक process control block रखेगा operating system. जब मैं minimize करती हूँ तो state change करता रहेगा, फिर minimize होता रहेगा. जब maximize कर रही हूँ तो state change करता रहेगा, running state करता रहेगा. Have you understood the scenario in the backend that your operating system is performing for you? How important it is, right? So this is basically when you are talking about the process execution, the kernel maintains different data structures. That is job queue, ready queue, and waiting queue. What is job queue? When you first start many applications, they are in the new state. When they are ready for the execution, they are in the ready state. When some processor are waiting for some IO request, then you can go into the waiting state. So there can be one or more processes which can be in new state, ready state, and waiting state. And that's the reason the queue is maintained for them, and that queue are given a specific name called as job queue, ready queue, and waiting queue. समझ में आया what is job queue, ready queue, and waiting queue? Right. So a new is the state when the program execution is started. The PCB of any process is in the job queue, then the state of the process is called as a new state. अगर मेरे PCB of any process के अंदर job queue है तो वो new state हो जाता है. This is also one kind of a queue information. Ready state means when the program is in the main memory and waiting for the processor to get the control. When I say the dispatcher will take a control of one process from ready to running आया मतलब उसको processor मिला, मतलब उसको CPU मिला. That is called as in the running state. So for that it maintains a ready queue. Running when a CPU is in executing a process. Exit when a process is terminated. Waiting when the process is requesting for any IO device, then process changes its state from running to waiting state. And when PCB of any process is in waiting queue of any device, right? So this is right. Ame in the ready, the definition should be process, not the program. Now in the ready queue, when the program is in the main memory, yes, it should be process. The word should be process. So when the process is in the main memory and waiting for the queue, then it is called as CPU. नॉर्मली ये दो टर्मिनोलॉजी हम लोग अब हमारे लिए यूज करते हैं कि प्रोग्राम मीन्स सेट ऑफ इंस्ट्रक्शन, प्रोसेस मीन्स एनीथिंग इन द एग्जीक्यूशन मोड, बट अल्टीमेटली यू क्रिएट प्रोग्राम्स फॉर द एग्जीक्यूशन, सो यू कैन यूज दीज टर्मिनोलॉजीज. ओके, नाउ when I say this part, dispatcher, these are the processes which takes your process from one state to another state. Can I say, ऐसे भी तो हो सकता है कि मेरा प्रोसेस न्यू से रेडी के पास जाएगा एंड देन रेडी से रनिंग के पास जाएगा. एवरीवन, इट इज बट ऑब्वियस, राइट? कभी कभी आपने सपोज 10 एप्लीकेशन स्टार्ट किया, राइट? आउट ऑफ 10 एप्लीकेशन सपोज 8 एप्लीकेशन स्टार्टेड और 2 एप्लीकेशन करप्टेड है, तो वो क्या स्टार्ट होती है क्या? ऑब्वियसली नो. दैट मीन्स when you are giving 10 applications for opening, then those are in the new state, out of which 8 are successfully ready for you, so 8 will go into the ready queue. Are you getting? 8 will go into the ready queue. So there should be someone who can take your application, your process from this state to this state or from this state to this state. That is called as schedulers. There are 2 categories of schedulers. One is a job scheduler, another is a CPU scheduler. What is job scheduler? They are also called as long-term schedulers. When I talk about CPU scheduler, they are called as short-term schedulers. These terminologies you need to remember. In your CCAT, questions can be asked. Long-term schedulers are also called as, answer should be job schedulers, right? Read this. It selects which process should be brought into the ready queue. मतलब can I conclude, जब मेरा process new से ready में आता है, this is managed by long term scheduler. And जब मेरा process ready to running में जाता है, those are managed by short term schedulers. These are the naming conventions given. Okay, so processes from ready queue to load into the CPU is done by your CPU schedulers. Akshay, I will come to your point that paint and music app at a time कैसे run होती है. You will get the answer. Don't worry. Let me cover process scheduling algorithms. तब आपको समझ में आएगा. For time being, keep it on hold. Right. Select which process should be executed next and allocated the CPU. Ab, listen. If I'm talking about long term, it means whatever applications I wanted to have 10 out of which 8 got executed. तो ये जो decision है 8 applications are working fine, new से ready में long term में schedulers लेके आएंगे. Whatever process I wish to execute, to whom I want a control of CPU, then those are done by short-term processors. So short-term processor decides which process is to be executed next and allocated CPU. अब ये कैसे डिसाइड करते हैं कि कौन सा प्रोसेस पहले जाना चाहिए, कौन सा प्रोसेस बाद में? फॉर दैट वी हैव प्रोसेस शेड्यूलिंग एल्गोरिथम्स. वी विल सी दैट. So what is dispatcher? It gives a control of the CPU to the process which is scheduled by CPU schedulers. So short term को हम CPU scheduler भी बोलते हैं. क्यों? क्योंकि short term वाले जो schedulers है, they are the one who takes my process to the CPU. That's why they are called as CPU schedulers. Right? Now, this terminology was asked once. What do you mean by dispatcher latency? The time taken by dispatcher to stop the execution of one process and start the execution of another process is called as dispatcher latency. That is, suppose P1 is being taken from ready to running. P1 have gone into the waiting queue. मतलब मेरे ऑपरेटिंग सिस्टम को P1 का रनिंग स्टॉप करना पड़ेगा. यस. ऑपरेटिंग सिस्टम को नेक्स्ट P2 अब रनिंग में लेके आना पड़ेगा. यस. That means one process P1 have been stopped because it was having a wait. It was going to go in the waiting state. Next process P2 I have to take into the running state. That is called as कितना टाइम लगा. 1 millisecond, 2 millisecond, 3 milliseconds, and so on. So it is basically based on how much time the dispatcher have taken to stop the one process and to move a process from ready to running for its execution. That terminology is called as dispatcher latency. Have you understood? Everyone. Saurabh, long term में लॉन्ग टर्म वाला जो स्केड्यूलर है वो न्यू से आपको रेडी क्यू में लेके आएगा. ओके. रेडी क्यू में आने के बाद वापस वो डिस्पैचर आपको रनिंग में लेके जाएगा. रनिंग से अगर वेटिंग है तो फिर से वेटिंग क्यू में जाके फिर से वो रेडी में जाएगा. एंड सो ऑन until and unless you do not close this. There will be remaining in the ready queue, Saurabh. P1, P2, P3 जो आपने आउट ऑफ 10 में से 2 डिस्ट्रॉय हो गए वो तो ओपन ही नहीं हुए ना, तो वो मेरे प्रोसेस स्टेट डायग्राम में ही नहीं आए. ओके सौरभ, आर यू गेटिंग इन? यस. So this is basically the process state diagram, the meaning of scheduler and the dispatcher. Have you understood up to this point? All right. Now, suppose I am saying I have two processes. I'll take a diagram first, then I'll take a theory. Suppose I have process P0 and I have process P1. Process P0 is executing up to this point, right? Let us say for 10 milliseconds. Then process P0 is now idle. Idle means मैंने उसको minimize करके रखा है, right? Then process P0 is again executing, let us say for few milliseconds. Now, if you ever have observed, when I am minimizing this, let us say I'm now on 11th number slide, okay? And I'm minimizing it. I'm going to this paint. When I maximize it, क्या वो मुझे first slide पे लेके गया क्या? नहीं. The reason is, first of all, I will say, let us assume my PDF is process 1. Maybe my paint is process 2. Maybe in my process P1, I am at slide number 11. Then I am working on it. When I'm saying I'm working on it, can you please tell me when I'm working? So I'm in which state? I'm in which state? Running state. Now I have performed next operation as minimize. जैसे ही minimize किया, can I say I will go back to which state? Ready state. At this location, I am again going to paint. And now I'm working on paint. Can I say now I'm in running state? Again, I will say I have minimized it, means I am in ready state. Again, I'll go, let us say to P1, then obviously I will be in the running state. Now, when I will come back to running state, will it take me to same slide number 11 only? Of course, yes. This is called as, here, when for the first time I have said I was at slide number 11, this concept is called as saving the state, that is state save. My operating system saves the state of the process whenever the process is moving from one state to another. Now, I am saying it will take me to the same slide number. Means, can I say this is restoring the state? Is it restoring the previous state? Of course, yes. So, can I say also over here, I am moving from one state to another state. I am switching from one application to another application. That is called as context switching. What happens in context switching is we try to switch from one application to another application. But in the background, what my operating system do? It will perform the state save and it will restore the state. So what is context switching? Save the state and whenever I'm opening it back, it please restore it at the same state. समझ में आया? What is context switching? Switching from between one process to another process is called as context switching. So obviously, when I'm talking about I am working on two different processes, can I say this will have definitely two process control blocks? This will be the PCB of process P1. This will be the PCB of process P2. जब मैं यहाँ पे बोलती हूँ I have a RAM memory allocation, right? Main memory. When I say I am working on process P1, the PCB of process P1 is brought into the main memory for the execution. Next, when I'm saying I'm minimizing it, means process of PCB1 is brought into back to your disk maybe or somewhere aside. Then PCB of 2 will get loaded again into RAM. Again, PCB of 2 may be brought out of it. So this process switching from one process execution to another process execution is called as context switching. Whenever we perform context switching, in that case, PCB of that block or PCB of that process is either brought into the RAM or came out of the RAM or brought out of the RAM. And your context switching of the processes basically follow state save and state restore. So, isn't PCB generated in the CPU itself? No, CPU is only for processing, Shrikant. ये सारा आपका मेमोरी के रिलेटेड और कर्नल एंड यूजर करता है, कर्नल मोड, यूजर मोड, कर्नल स्पेस, यूजर स्पेस. तो जो आपका कर्नल स्पेस है उधर सिर्फ पीसीबी लोड होता है. दिस इज हाउ इट इज. नो अक्षय, जस्ट होल्ड ऑन. Just hold on. I will give you answer for it. I'll give you answer. Not to worry. ठीक है? Don't worry. I'll give you answer. So, when the CPU switches to another process, the system must save the state of old process and then load the saved state of the new process. This is called as context switch. Context means context of a process is represented into the PCB. Context means अब उसका state क्या है, अब उसने क्या operation perform किया है, and so on and so forth. So representation of any process inside your PCB is nothing but the context. Context switching time is overhead. System does not do useful work while switching. जब मैं सिर्फ स्विच करती हूँ, वो ऑपरेशन क्या परफॉर्म करता है? पीसीबी को यहाँ से लेके यहाँ पे लेता है, इस पीसीबी को यहाँ से लेके यहाँ पे लेता है. तो मतलब सीपीयू यूटिलाइजेशन ज्यादा नहीं होता है प्रोसेसिंग के लिए. आई एम टॉकिंग अबाउट. So the more complex the OS, the PCB, the longer is the context switch. कभी कभी आपने ऑब्जर्व किया है क्या? आपने 10 एप्लीकेशन या 20 एप्लीकेशन ओपन किया और आप ऑल टैप करते हो. अब मेरे पास थोड़े से एप्लीकेशन ओपन है, एकदम फास्ट से मेरा स्विचिंग हो रहा है. But when you talk about 100 applications which are opened, in that case, sometimes switching from one application takes little more time. Have you ever observed? Have you ever observed that? Yes, it is because background में your OS is trying to save the state of one PCB, then restore it the another process from the previous. So that time it takes. That's why हम लोग बोलते हैं कि अगर multiple applications open किए हैं, अगर use में नहीं है तो उसको बंद कर दो. क्यों हम बोलते हैं? बिकॉज उतना मेरा कॉन्टेक्स्ट स्विचिंग कम होता है. जैसे ही मैं ऑल टैप करती हूँ, इन दैट केस योर कंपाइलर विल, योर ऑपरेटिंग सिस्टम विल सी, okay, this I have to go for, this I have to go for, and so on and so forth. So accordingly it will switch. Switching takes time. That's why it is a time consuming task. Okay, so context switching is state save plus state restore. To save the execution context of the suspended process in PCB, state restore means restoring the execution context of the process which is scheduled by the CPU scheduler on the CPU register. So as I've given, process P1 is executing, uska state save karega, dot dot dot. Process P1 is starting executing, तो वो load करेगा PCB1 उसका. Again, it will try to execute. Maybe there are some system calls, maybe there are some interrupts. Again, I'm saying now P1 have completed a task. It will save the state of PCB1. Again, I'll come back over here. Now this is getting executed. This is starting maximize kiya. It will reload the state from PCB0 and it will perform the operation. So from running CPU scheduler means what? The dispatcher basically gets called जब मैं running से terminated में जाती हूँ, running से waiting में जाती हूँ, running से ready में जाती हूँ, या waiting से ready में जाती हूँ. In all these four cases, the dispatcher or scheduler is having the task of switching. Did you all understand what is the meaning of context switching? Everyone. All right. Any questions so far? If no, then I will proceed ahead. All right. So we have seen what is PCB, what is context switching, what do you mean by process, and we have seen what is job queue, what is maybe you can say ready queue, what is waiting queue, and so on, right? Now we will go ahead to the topic which is called as scheduling. As I said, I have a ready state, I have a running state. Assume in this ready state, there are P1, P2, P3, P4. 4 processes are waiting. I have a running state in which I can transmit either P1 or P2, P3 or P4. Of course, yes. So obviously, I will have someone who is called as scheduler or CPU scheduler, और इसको हम बोलते हैं short term scheduler, right? Now, or you also can talk it about as dispatcher. Now the question comes, how your dispatcher will decide? How your dispatcher will decide which process is to be taken next? Obviously, yes, it cannot take your multiple processes together. It cannot take multiple processes without some kind of criteria. There can be some criteria via which your dispatcher can take a process from this ready state by moving to running state. Now, how part is basically answer is by performing process scheduling. What does the process scheduling decide? It decides which process to dispatch to run the next, right? So in multi-program system, several processes compete for single process. I have many applications which are running and everyone is competing for getting the process fast. In that case, your operating system uses process scheduling, and for that we have algorithms. समझ में आया? How is basically by following process scheduling. All right. Now, when we talk about process scheduling, there are major two categories. One is preemptive, another is non-preemptive. For example, suppose I have process P1, I have a ready state and I have a running state, right? I'm saying I have P1 and P2 and maybe P3. First of all, assume dispatcher is taking process P2 for execution. Now there can be two categories. मैं बोलती हूँ P2 process, please complete its whole execution. Complete its whole execution and then directly terminate. And I'm saying P1, यहाँ पे मैं बोलती हूँ do the partial completion and it is absolutely okay for us right? If we go back to ready state. So that means here complete its whole execution means what? The control of the CPU will be given to the process P2 for its complete execution. Means एक बार अगर P2 को रनिंग स्टेट मिल गया डायरेक्टली P2 टर्मिनेशन में जाएगा कंप्लीट करने के बाद ही. P2 को मैं फिर से रेडी में नहीं डाल सकती. This type of process is called as non-preemptive. Preemptive. But if I say any process which I can switch from ready to running, running to ready, running to waiting, and so on, then those processes are called as, or that category is called as preemptive category. A non-preemptive processes cannot be removed from the running state, cannot be removed from the process execution until and unless they have finished its complete job. A preemptive state is the state in which a process can be removed based on the scenario from running to ready, running to waiting, or maybe running to terminated, wherever it is. Have you understood the terminology non-preemptive and preemptive? So, in multi-programming system, if a process can be removed from the run state before it completes its block, then it is called as preemptive. Non-preemptive means what? A process cannot be removed from the running state before it completes or blocks. समझ में आया? That term I'm talking about terminology. कैसे वो preemptive होता है, कौन सा algorithm है, कुछ algorithm preemptive रहते हैं, कुछ non-preemptive रहते हैं. But understand the terminology first. Yes, Ashwin, I'll talk about you can say processing time given to each process. That is what is scheduling is basically. But did you all get it up to this point? What is preemptive and what is non-preemptive? Right. Shall we go ahead? We will see different algorithms of preemptive and non-preemptive. Right. Before going to algorithms, yes, Aisha. Aisha is asking if one process is running, its PCB1 is created. When I context switch to the other process, PCB2 is created. So both the blocks are present in the kernel mode. They are available in the kernel space, not the mode. Okay, Aisha, there are two things, kernel space and the user space. User space means आपके जहां पे भी आपके processes रहते हैं वो execute होते हैं, but उन जो भी processes का PCB रहता है वो kernel space में रहता है. So accordingly, it will do the context switching and perform the operations. कर्नल मोड में कब जाता है? जब आप उसको एक्सप्लिसिटली सिस्टम लेवल एप्लीकेशंस एग्जीक्यूट करते हो. फॉर एग्जांपल, इफ यू आर इंस्टॉलिंग न्यू ड्राइवर्स, यू आर मेकिंग सम मॉडिफिकेशंस इनटू योर ऑपरेटिंग सिस्टम, यू आर टचिंग द इंटरनल पार्ट्स ऑफ योर ऑपरेटिंग सिस्टम, देन योर सिस्टम विल मूव फ्रॉम यूजर मोड टू कर्नल मोड. Okay, sometimes you might have seen a pop-up box, this need administrator permission and so on. So it is because it is asking you whether I should touch your OS for performing some changes into that OS. All right. So this is basically about your answer, Aisha. Now we will go ahead to process scheduling. Process scheduling में बहुत सारे algorithms है. First come first serve, shortest job first, priority, round robin, multi-level queue, multi-level feedback queue. Now you might be having a question, which operating system uses or which processor uses which kind of scheduling algorithm? So my answer will be every processor uses combination of these algorithms based on the design of that process. I cannot say कि I have a processor which always go for first come first serve. I have a processor which always goes for shortest job first and so on. Every processor uses combination of scheduling algorithms based on its design. But we will see all the algorithms working one by one, right? So FCFS is the first algorithm called as first come first served. SJF is shortest job first. Third is priority scheduling. Fourth is round robin. Fifth is multi-level queue. Sixth is multi-level feedback queue. Now, let us start with the first algorithms. But जब भी हम algorithms की बात करते हैं, कोई भी algorithm की बात करते हैं, in that case, there are some optimization criteria. For example, when I use any algorithm, how much is the CPU utilization? Utilization of the CPU must be as maximum as possible, otherwise CPU idle रहेगा तो मेरा processing slow हो जाएगा. Throughput means how much total work done per unit time. Throughput means how much output it is giving me, whether my program is executing in how many seconds, how much output it is giving, how it is working properly or not, whether it is giving me the fast answer or not. That is basically throughput is. So throughput also must be as maximum as possible. Third criteria is waiting time. For example, when I'm saying I have a ready state and running state, या running state में मैं waiting queue में आती हूँ, मुझे कितने टाइम के बाद प्रिंटर मिला, मैंने कितनी देर ready queue में wait किया, that is called as waiting time. So it is the total amount of time spent by the process in the ready queue for waiting to get the control of the CPU. Waiting time must be as minimum as possible. Have you understood what is CPU utilization, what is throughput, what is waiting time? These all are the criteria that we can calculate. The other two criteria are turnaround time and response time. Turnaround time is equal to waiting time plus execution time. मुझे अगर let us say 10 minutes wait करना पड़ा and 20 minutes मेरा process execute हुआ, so total time will be 30 minutes, that is turnaround time. Okay, response time means what? It is a time required for the process to get the first response from the CPU on its submission time. One need to select such algorithm in which response time must be as minimum as possible. For example, I'll give you the difference between waiting time and response time. Okay, understand. Suppose there is one student. I'll take a generalized example. There is one student who is having a doubt. And suppose I'm saying, if you have any doubt, you can come down tomorrow and I will clear your doubt and you can come at 11 a.m. Okay. Suppose on the next day, that student came at 10:45. Okay. That student arrived at 10:45. Right. I have asked for the time at 11 o'clock. Right. But due to my other schedule, I have told my student, please wait for 15 minutes. I will connect you by 11:15 a.m. Means the time which was given to him was 11, but I was busy. So I have given, or it got delayed by 15 minutes. Then between 11 to 15 and between, let us say his doubt was for 15 minutes and maybe I have cleared his or her queries within this 15 minutes time. So ये हुआ doubt clearing session. Okay, so for 15 minutes, I am the processor and the student is, let us say, a process. In that case, the process have got the control of the processor for 15 minutes for doubt clearance. Have you understood up to this point, everyone? Yes. Now, suppose one more student have told me, I have only one query, please give me 5 minutes, right? So what I'll do, I will tell my first student, please wait for 5 minutes, right? Means that student has to wait from 11:30 to 11:35 a.m. From 11:35, I have maybe cleared the doubts of other students, right? So this is in between, I have cleared the doubts of other students, right? Again, the first student have got the control for the processor. Maybe that student is saying, now I want only 5 minutes of you and my doubts will get cleared. So again, for next 5 minutes, I'm clearing that same person's doubt. Have you understood the scenario first, everyone? Yes. Now, can you please observe and tell me, मेरे इस process P1 को, I'm saying student 1 as process P1, उसको total कितना time चाहिए था execution करने के लिए? 20 minutes. Can I say like this? Because first time he have taken 15 minutes and he said, I just need 25 minutes, so 20 minutes are done. यहाँ तक समझ में आया? Everyone, this is called as execution time, or this is called as burst time. This is called as time required by the process for its execution. Is this point clear, everyone? Yes or no? Yes. Next, CPU utilization is not calculated as time. It is basically how fast it is basically how fast we have got. Now, next question is, if I ask you, can you please tell me what is a waiting time for P1? Ab, can you please tell me what is a waiting time? Waiting time for the P1 for the first time was 15 minutes. And बाद में 5 minutes दूसरा wait किया उसने. Are you getting why 15 minutes? The reason is, अगर वो, ये बहुत इंपॉर्टेंट पॉइंट है, अगर वो स्टूडेंट सुबह को 8 o'clock को अराइव किया, he cannot say कि मैम I was waiting since 8 o'clock, so it's around 8, 9, 10, 11, 4 hours 15 minutes I'm waiting for you. He cannot say like this. Why? Because the arrival time that I have given to that student was 11. तो उसको मैंने कंट्रोल कभी दिया 11:15 को. इट मींस आई हैव गिवन 15 minutes as a waiting time for that process for the execution. Please understand, आप ऐसे नहीं बोल सकते कि this process when it arrived at 10:45 means that process have waited for me from 10:45 to 11:15 for 30 minutes. No. Have you understood the what is waiting time? Not near the arrival time, at the arrival time, you can say. इस arrival time से, this is my arrival time, इस arrival time से मैंने waiting कितना कराया 15 minutes, तो इस process का waiting time हो गया 15 minutes. Is it okay, everyone? So this is called as waiting time. Correct? What is turnaround time? Waiting time plus execution time. Waiting time कितना था? 15 plus 5. That means 20 minutes was a waiting time. उसको execution कितना चाहिए? 20 minutes. Now 15 plus 5 is 20 minutes. 20 plus 20. Total उसको turn around time कितना लगा? 20 minutes for the execution, 20 minutes for waiting, तो 40 minutes लगा. Have you understood the meaning between turnaround time, waiting time, and execution time or burst time? Everyone. Right. Now coming to the point called as response time. What is response time? Response time means first time उसको CPU control कब मिला? First time कितने बजे मिला? 11:15 को मिला. Means after submission उसको 15 minutes हुआ उसका response time. Is it okay? If you wish, I will save this. These are CPU criteria. Scheduling criteria जिसको हम लोग बोलते हैं. अगर आपको ये एग्जाम्पल समझ में आया, रेस्पॉन्स टाइम मीन्स व्हाट आर दे? पहली बार मुझे सीपीयू का कंट्रोल कितने बजे मिला? 11:15 को. First time when the process have got a CPU control is basically the response time. Is it okay? Yes. So instead of reading the definitions, I hope execution time, burst time, CPU burst time, running time, jo bhi bolo, all the terminologies are same. So instead of explaining the definitions, I hope now with this example, you are clear with the explanation of these times. Right. My execution means I'm saying how much time I require for my execution. Means I'm saying I have this process and this process requires 20 minutes for execution. So that is execution time. It is also called as burst time also. Got it? Any questions? Are you guys there and understanding the things properly? Though it is theory subject, but little bit conceptual and little bit, you can say, concepts are there. So I'm trying to make it more interactive so that you can understand. Right. It's too much theory. Yes, Sajan. Yesterday also you have said so, but I cannot help. It is the thing that these all are the subjects that you have to do. Okay? Response time is between 11 to 11:15. Yes. क्योंकि उसको first CPU control कब मिला? That is response time. No, Tushar. Ready queue का time नहीं consider करेंगे. All right. Have you understood up to this point? So that I will go to the first algorithm. First come, first serve. Right? Now, I'll draw the diagrams over here. It will be more better actually. First come, first serve. Now, whenever I am considering first come, first serve, consider in these types of example, आपको ये टॉपिक समझ में आना चाहिए, इसलिए हम algorithms ले रहे हैं. But in your question papers, sometimes it is asked कि please calculate this and so on and so forth. Concept समझाने के लिए मैं आपको ये सारे algorithms short में explain करती हूँ. right? Now, whenever you have a number of process scheduling algorithms, in that case, the first algorithm is first come, first serve, which is called as FCFS scheduling. And whenever you have process scheduling algorithms, you will be given a process name and the burst time. What is burst time? It is basically a CPU execution time. कि प्रोसेस P1 को 24 मिलीसेकंड सपोज लगते हैं फॉर इट्स एग्जीक्यूशन, प्रोसेस P2 को लेट अस से 3 मिलीसेकंड्स लगते हैं फॉर इट्स एग्जीक्यूशन, प्रोसेस P3 को 3 मिलीसेकंड्स लगते हैं फॉर इट्स एग्जीक्यूशन. So I will start with the first, let us say, suppose sequence of processes are P1, P2, P3. हमारे पास CPU ने ये डिसाइड किया कि प्रोसेस P1 पहले एग्जीक्यूट करेंगे, P2 बाद में, P3 देन. This is FCFS algorithm where the process request which came first will completely get its execution. I will explain whenever you are trying to explain this particular algorithms, we type or we draw a Gantt chart. We draw a Gantt chart for this. So I will say there is a process P1. There is a process P1, which is if it starts at 0 millisecond, it will go up to maybe 24, let us say. First millisecond से let us say up to 24. अब ये किसको टाइम मिला? CPU का P1 को मिला. P1 have completed its job. The next process which comes as P2. P2 says I just need 3 milliseconds. So next P2 को time मिलेगा 24 to 3, that is plus 3, that is up to 27 milliseconds. Next, P3 is coming. P3 is saying, I also need 3 milliseconds. So next time will be allocated for your P3 process and P3 will also execute for 3 milliseconds, that is 30. So P3 have completed its job. P2 also have completed its job. So the first process which came first will get executed first. Second important point, in case of first come, first serve, पहला process आया, complete its execution, next process will be taken only if the first process have completed its job. Can you please tell me category of this type of algorithm? Is it a preemptive or non-preemptive? It will be 100% non-preemptive. Because जब तक पहला process complete नहीं करता है, execution complete, next process will not be taken. This category of algorithm is called as non-preemptive. So we can say that first come, first serve algorithm is non-preemptive algorithm. समझ में आया अभी कैसे कैटेगराइज करना है, preemptive क्या है, non-preemptive क्या है? Right. Now, first of all, I will try to calculate a waiting time. Waiting time for P1. P1 को कितना टाइम वेट करना पड़ा? Obviously 0. वेटिंग टाइम फॉर P2, उसको कितना वेट करना पड़ा? 24 तक. वेटिंग टाइम फॉर P3, उसको कितना वेट करना पड़ा? 27. If I say I want to calculate average waiting time, can I say it will be 0 plus 24 plus 27 divide by 3 because 3 processes है? Can I say like this, which is equal to 17? तो कब 27 कैसे? Because P3 को CPU कंट्रोल कब मिला? 27 तक मिला ना. P2 को कब मिला? 24. तो ये उनका वेटिंग टाइम हो गया. Is it okay? Is it okay, everyone? Now, I have said I have got average waiting time. अब, let us consider another scenario in the same example. Suppose I'm saying if I would have considered sequence as पहले P2, then P3, then P1. तो क्या होता था? P1, P2, P3. I'll just draw with the same color to save the time just. P1, P2, and P3. In this case, can I say this will be given at 0, this will be at 3, this will be at 6, this will be at 30. For this, P2 यहाँ पे आया, then P3 आया, and then P1 आया. क्या अब आप मुझे बता सकते हो P2 का वेटिंग टाइम क्या था? P2 का वेटिंग टाइम है 3. P1 का वेटिंग टाइम कितना होगा? सॉरी, P2 का वेटिंग टाइम इज 0. P1 का वेटिंग टाइम इज 3 एंड P3 का वेटिंग टाइम इज 3 एंड P1 का वेटिंग टाइम इज 6. Can I say like this? Everyone, अगर अब मैं कैलकुलेट करूंगी एवरेज वेटिंग टाइम, तो ऑब्वियसली इट विल बी 0 + 3 + 6 डिवाइड बाय 3. What will be the answer? What will be the answer? 9 divided by 3, that is 3 milliseconds. Assume. And here what I was getting? 17 milliseconds. Are you getting the scenario? Please observe. In this case, if the larger process gets CPU control, first it increases waiting time for all smaller processes. Can I say like this? अगर large process को पहले control मिला, तो obviously it will increase the waiting time for all the smaller processes. Means, can I say smaller processes are waiting for one big process to execute to get the control of the processor, right? This effect is called as convoy effect. What is convoy effect? अगर मेरे small processes को large processes के लिए wait करना पड़ रहा है and smaller processes are waiting for one big process to complete, then it is basically convoy effect. So FCFS algorithm faces which type of problem? Answer is convoy effect. As all the other processes wait for one big process to get off the CPU. जब तक P1 नहीं जा रहा, तो P2 और P3 को कंट्रोल नहीं मिल रहा. That is FCFS. समझ में आया? तो अगर मैं एग्जाम्पल नहीं लेती थी, तो आपको कॉन्वाय इफेक्ट का कंसेप्ट नहीं समझा पाती थी. That's why I have taken example. For exam point of view, you should be aware about it. It is not asked okay what exactly the average waiting time पूरा calculate करो and so on, but you should be aware. कभी पूछा तो आपको आना चाहिए. Is it fine? Have you understood FCFS? The same I've included into the slides. I'll share the diagrams too. The next says shortest job first. Okay. Shortest job first is basically, it is associated with each process, the length of its next CPU. It uses the length to schedule the process with the shortest time slot. So there are two categories. One is non-preemptive, another is preemptive. Let us consider that. For example, in case of shortest job, there are two things which are considered. Let us assume I have P1, P2, P3, P4. I have burst time 7411. Okay. And I am saying in the case of shortest job first, one more factor is given called as arrival time. Let us try to draw the diagram. I will say, first I will explain shortest job first, non-preemptive. Okay, I'll take the same example. So this is my process, arrival time and the burst time. This is the process, arrival time. Arrival time means just in the form of seconds. 0 second पे पहला process आया, second वाले second या second minute पे दूसरा आया, 4th minute पे third आया, and then इसको burst time 1 ही चाहिए, and finally 5th minute पे ये आया, and so on. Right? So this is what is basically some data which is given to me. I want to go for shortest job first, which is non-preemptive, right? SJF, non-preemptive. I will say non-preemptive hai process P1, what it requires up to 7. Process P1 will get executed. I cannot, even if I'm saying non-preemptive, means मुझे अब arrival time को देखना ही नहीं है. The reason is non-preemptive indicates once the process have got the control, I cannot take the control off from that CPU. This is just given for sometimes in for the confusion. Next, I'll say next process P2. P2 requires 4 burst cycles. So 7 plus 4, can I say it is 11? Next, P3 process comes. P3 will try to execute. P3 requires only 1 cycle. So this will be P3, which will go up to 12. right? While considering shortest job first, non-preemptive, initially do not observe into the arrival time. We will check it later at the time of waiting time. Next, I will say P4. So this will be P4, which have got 4 burst time, means up to 16. Can I say like this? This is what I've drawn the diagram. Have you understood up to this point? Right. Now I will calculate waiting time. For process P1, अब आप एग्जाम्पल याद रखो जो मैंने अभी आपको दिया. मैंने स्टूडेंट को 11 o'clock टाइम दिया था एंड आई हैव गिवन अ कंट्रोल एट 11:15, तो वो स्टूडेंट का वेटिंग टाइम कितना था? 15 मिनट्स, राइट? अगर वो स्टूडेंट 10 o'clock आता है तो मैं उसको ऐसे नहीं बोल सकती कि ही वाज वेटिंग फॉर 1 hour 15 minutes. ऑलराइट, सिमिलरली इफ आई से P1, देन और जब भी P1 है यू कैन से प्रोसेसर है शॉर्टेस्ट जॉब फर्स्ट में, how do you calculate waiting time? Waiting time can be calculated as 0 to, for example, P1 आया, उसका अराइवल टाइम क्या था? उसका अराइवल टाइम क्या था? 0. उसको कंट्रोल कभी मिला? 0. दिस इज 0. समझ में आया? 11:15 minus 11, only 15 minutes. P2, 7 को उसको कंट्रोल मिला, उसका अराइवल टाइम 2 है, तो इसका वेटिंग कितना हुआ? 5. P3, 11 को इसको कंट्रोल मिला, उसका अराइवल 4 था, एंड देन व्हाट इज द डिफरेंस? 7. P4 got the control at 12 and arrival time was 5, the difference is 7. What is the average waiting time? It is 0 plus 5 plus 7 plus 7 divided by 4, whatever it is. Have you understood? This will be average waiting time. Did you all get it? The need of arrival time in case of SJF? सबको समझ में आया? Everyone. Good. This is very easy. That is non-preemptive SJF. Okay, it have taken from 0 to 8, however it is. ठीक है. Let us talk about SJF, which is also called as shortest remaining time first. Now, please concentrate here very carefully because here there is little confusion. सबको non-preemptive पहले समझ में आया क्या? So that I will proceed to preemptive now. Okay. Just give me a moment. All right. So I will save this. Now I will explain SJF preemptive. In case of preemptive, arrival time plays a very important role. The reason is when I'm talking about preemptive, it means the control of the program, or the process can be taken out from the CPU. That is called as preemptive. Right? Now, let us observe very carefully because this is little bit confusing. I'll just decrease the font size. ठीक है. अब ये है, this is the given question. First of all, let us say process P1. Okay. Process P1, I'll draw a complete Gantt chart now. Process P1 have got first control. I'll say process P1. Can you please tell me arrival time 0 तक कौन सा प्रोसेस आ चुका है? ओनली प्रोसेस P1. मतलब मेरे पास 4 स्टूडेंट्स है, एक को मैंने टाइम दिया 11, एक को मैंने 11:10, 11:20, 11:30. अज्यूम लाइक दिस. तो 11 o'clock तक कौन सा प्रोसेस आ चुका है? मींस 0 तक सिर्फ प्रोसेस P1 आ चुका है. कैन आई से लाइक दिस? आई विल राइट अ बर्स्ट टाइम आल्सो ओवर हियर फॉर योर रेफरेंस. प्रोसेस P1 का बर्स्ट टाइम है 7. ऑलराइट. नाउ if I say it's a preemptive, am I given the next arrival time? What is the next arrival time? 2. So here next arrival time is 2, तो मैं यहाँ पे 2 लिखती हूँ. Okay. Now, can you please tell me arrival time 2 तक कौन से प्रोसेसेस आ चुके हैं? एक प्रोसेस P1 और एक प्रोसेस P2. Do you all agree? Everyone. अब प्रोसेस P1 ने 7 उसका बर्स्ट टाइम था, उसमें से प्रोसेस P1 ने 2 साइकिल्स उसके कंप्लीट किए. व्हाट इज द रिमेनिंग टाइम फॉर प्रोसेस P1? 5. Process P2 have just arrived. What is the remaining time, burst time for process P2? 4. यहां तक समझ में आया? Everyone. All right. Now the question comes. I have 2 processes ready for me. Process P1 having the burst time as 4. Process P2 having the burst time as 4. अब कंट्रोल में P1 को दूं कि P2 को दूं? Which algorithm I am using? Shortest job first. Which algorithm I'm using? Shortest job first. When I'm saying shortest job first, right? In that case, पहले बार इन दोनों में से कौन है शॉर्ट? P1 P2 में से P2 is the shortest. So I will take P2 first. So can you please tell me next control अब किसको मिलेगा? P2 को मिलेगा. समझ में आया मैंने कैसे प्रोसेस को सिलेक्ट किया? Everyone, right. What is the any next arrival given? Yes, next arrival क्या दिया गया है? 4. Okay, so I will write it here, 4. Now can you please tell me everyone, process P1 का 4 जब तक 4 arrival time है तो कौन से प्रोसेसेस आ चुके हैं? P1, P2, P3. Do you all agree? Right. P1 का रिमेनिंग टाइम क्या था? 5. P2 का रिमेनिंग टाइम क्या रहेगा? 2, because 2 cycles it have executed. P3 have just arrived. What is the P3 burst time? 1. अब आप मुझे बताओ नेक्स्ट कंट्रोल किसको जाना चाहिए? Who is the shortest? P3 is the shortest. So next control will be given to P3. Are you understanding the scenario? Everyone, right. Am I given the next arrival time? Yes. So next arrival time is 5. Next arrival time is 5. अब can you please tell me 5 तक कौन से प्रोसेसेस आ चुके हैं? एक P1, P2, P3, P4. P1 का रिमेनिंग टाइम इज 5. P2 का रिमेनिंग टाइम इज 2. P3 0. P4 का just arrived 4 is a burst time. Means P3 will go into which state? Terminating state. I'll draw little smaller. P3 will go out. Have you understood? Everyone. Next, if I'm saying P1, P2, P4, who is the shortest? P2 is the shortest. Next control will be given to whom? P2. Am I given the next arrival time? No. P2 will complete its operation. अब P2 को कंप्लीट करेगा कहां तक? उसको 2 ही बाकी है तो ये 7 रहेगा. P2 2 कैसे? बिकॉज P2 ने यहाँ पे 2 एग्जीक्यूट किए थे ना देवीदास ऑलरेडी. 4 में से 2 इधर एग्जीक्यूट किए, 2 इसके बाकी है. ओके एवरीवन. नाउ P2 have completed its job. Means when I am reaching at this, P1 was still remaining. P2 have completed. P4 is still remaining. P1 have complete. P2 have completed. Means this is out of this. Right? Who is the smallest now? Obviously P4 is the smallest. Who will be given the control? Obviously P4 will be given the control. Next P4 will complete its execution. जब तक arrival time दिया था तब तक हमने follow किया. नहीं किया, converted into non-preemptive, executed fully up to 11. अब at 11 can I say P1 is 5 and P4 is 0? Obviously P4 have completed its job of operation. Last में अब किसको कंट्रोल मिलेगा? P1 को मिलेगा and P1 will complete its execution, which is nothing but 16. Did you all get it up to this point? So finally my P1 is also 0. This algorithm is called as shortest job first, that too preemptive category. I will save this diagram. While revising, I request everyone, आप यही diagram देखना instead of looking into the slides. You will understand when you revise. You will understand in more better way. राइट. सो अब आप उसका कैलकुलेट कर सकते हो एवरेज वेटिंग टाइम, राइट. P1, लेट अस ऑब्जर्व एवरेज वेटिंग टाइम फॉर P1. P1 का अराइवल टाइम कब था? P1 का अराइवल टाइम था 0. P1 को सीपीयू कंट्रोल कभी कभी मिला था, एक 11 पे मिला, एक 0 पे मिला था, राइट, और उसका 0 था. डू यू अग्री एवरीवन? सो उसका वेटिंग टाइम हो गया 11. P2, P2 को कंट्रोल कभी कभी मिला, एक 5 पे मिला था, एक 2 पे मिला था, और उसका खुद का वेटिंग टाइम था 2. कैन आई से इट विल बी 1. P3, P3 have got the control at 4, waiting time arrived at 4, waiting time 0 हो गया. P4 got the control at 7, arrival time was at 5, waiting time is 2. This is called as waiting time for all the processes. You can calculate average by dividing addition and divide by 4. Is it okay, everyone? I'm sorry, in this non-preemptive, I will just check, I'll just let you know. P1 is basically, अच्छा यहाँ पे मैंने 0 to 8 लिया है, that's fine, ठीक है. Now we will take this example one more time. There's a little mistake into it. I'm so sorry. I'll take it. I'll just go to preemptive, non-preemptive, and I will edit it. There is one mistake. We have not followed the shortest job first category. ठीक है. Let me first complete this. SDF समझ में आया क्या सबको? Preemptive, everyone? Have you got how we have calculated waiting time? Right. Okay. I'll just save this. I'll go back to SDF non-preemptive. One mistake that we have done over here. I'll just remove. I'll explain one more time. Now, whenever you have shortest job first, पहला process P1 आया, right? I'll write it. पहला process P1 आया. P1 is going from 0 to 8 because it is having the burst time up to this. All right. Now, I'm so sorry for it, but let me just complete. Now, when I'm saying arrival time 8 हो गया, here P1 is basically 0, P2 is basically 4, P3 is basically 1, and P4 is basically 4. Can I say like this, everyone? At this location? Yes or no? Right. अब P1 का तो calculation हो गया. Next, I did not follow the algorithm actually. Algorithm says shortest job first. Who is the shortest among these three? P3 is the shortest. Who is the shortest? P3 is the shortest. तो पहले ये P3 execute करेगा. आया समझ में? P3 का complete execution is of 1. So यहाँ पे आएगा 9. Can I say अब remaining is P2 is 4 and P4 is 4. These are the remaining processes, everyone. Now, in this scenario, P2 and P4 में से shortest कौन सा है? कोई भी नहीं, दोनों भी same burst time के हैं. So the one who came first was P2 will get the chance first, that which is P2. So P2 will get up to 9 plus 4 is 13. And P4 will get up to 4, that is 17. समझ में आया? We have not assumed a shortest process first. Is it okay? Yes, you can assume one, whatever it is. Ultimately, you will get the answer. Have you understood up to this point? We should check. Okay, I'll start from 1. Let us say we should always check which algorithm it is, and accordingly we should proceed, right? The one mistake which we have done in the last example was 4 and 4. ये दोनों भी same process है, तो हम लोग ने sequence में ले लिया. The algorithm says shortest job first. जो पहला process आया उसको पहले control मिलता है नरेंद्र, बाद में मेरा algorithm work करता है start करना. Okay, have you understood up to this point SDF non-preemptive and SDF preemptive? SDF non-preemptive means हम लोग process को preempt नहीं कर सकते हैं. In that case, first process will complete its execution. Process 2 onwards, it will check the priority. Preemptive में were we observing shortest remaining time of all the processes? That's why your preemptive is called as SRTF also. Once the question was asked, what do you mean by SRTF? Full form is shortest remaining time first. Another name is preemptive SJF. समझ में आया everyone? Have you understood up to this point? All right. I'm sorry for that SJF, but please do revise, right? Preemptive and non-preemptive, दोनों categories आप लोग फिर से एक बार video recorded session सुनो, and then you will be able to understand, right? Still, if you have any queries, I will solve it tomorrow, and tomorrow I will continue with priority, round robin, and multi-level queue algorithms, right? So with this, I will stop the recording. We'll be uploading it soon. Say it is nothing but one